Our first paper is by Professor Nicolas Holliman from Newcastle University. He is Professor of Visualisation at Newcastle University in the UK, and Nick studies the science and engineering of interactive media using the fundamental challenges of stereoscopic 3D visualisation, and he's been involved with the Stereo Conference now for a very, very long time. Not as long as me, he says. All right, over to you, Nick.
Okay, thank you. Good afternoon. So when I first submitted this abstract, it had a slightly different purpose, and I was going to talk mostly about technical things to do with designing software, but within this visualization facilities session, I have a different goal. And actually, it was quite interesting, thinking back over the visualization facilities I've built and run over the years, and how they're different from the ones we're building and running at the moment. And at Newcastle, as you'll see, one of the reasons I moved there 18 months ago is we've got a lot of opportunity for building new things and trying new things out. A few co-authors there have helped us build some of the software infrastructure I'll talk about today, and I'll come back to that in a second. Steve, you might want to start my timer. Getting a free minute. But one of the things I try and do in most talks now is talk about what I think visualization is, because I'm not sure that everyone has quite the same ideas about it. And mostly, for me, it's about going from data to ideas. And most of what visualization is about putting ideas into people's heads. This bit over here. The bit where we take stuff in the cloud, we process the data, and we generate the picture is the technical side of visualization, which is all very interesting. But if we can't get the right idea into someone's head at the end of the day, they can't understand things and they can't make decisions. And as part of that, there are a few roles that visualization has. And I think one of them is communicating ideas. We do that here a lot. One of them is confirming ideas. Scientists use it a lot to confirm or not confirm ideas. And to explore data. And we're increasingly doing that now within the Digital Institute. We're seeing lots of people bringing enormous buckets of data to us and saying, what does it mean? Within the context of the modern world, there's perhaps a role of visualization for identifying facts, what they might be and what they might not be. And in fact, we've just put in quite a large grant proposal around the validity of visualizations, which we hope we'll get next year. When we're teaching visualization, which we do quite a lot of, we're very interested in telling people what it might help them do. And the simple thing it might help them do is zoom up this arrow from data to wisdom more quickly. If you can get visualizations out which help people understand things, perhaps we can do that. So, designing visualization facilities. This was interesting to think back to the very first ones I've built. And the first ones that we built were at Sharp in the late 1990s, where we built an awful lot of stereoscopic displays of different types. And we had many quite complex hardware interfaces to what at the time were quite novel display systems. We definitely had a 3D projector, and throughout all of the different labs I built, we've always had some kind of 3D projection. A large screen 3D always works very well, both for testing images and for showing visitors things. But we supported many autostereoscopic displays, which led to a series of products from Sharp, laptops, desktops, mobile phones, and the most successful one was the Nintendo 3DS system. And we used platforms for a while. SGI was the only thing we could buy to drive things, and PCs slowly began to take over. When I was at Durham, we built a whole series of visualization things in a very large room, lots of good space, but again, driven mostly by 3D projection, large screen 3D. And again, we had a large collection of stereoscopic and autostereoscopic displays as the display industry started to build lots of the different types. And as the SGI faded out, we went to PC and ended up with PC. And we made a mistake of going through Mac in the middle. Mac was a technically bad choice for us because it didn't support a lot of these unique 3D displays in quite the same way that the Windows and PCs did. So I think that technical choice there actually slowed us down by a year or two in some things we did. And then at York, a similar thing, we set up a whole series of things actually. We had a 360 room, which was a room about sixth of the size of this room with projection on all of the walls and the floor. And the most difficult thing about that was authoring content for it. If Facebook's camera had been around, that might have helped a lot. But in many of these systems, my interest is in producing images and producing content, and it's the repeatability of the content across a range of different platforms that interests me. We looked at VPix's active stereo systems, and we got some Oculus systems we tried out as well. And the platform was uniformly by then PC and NVIDIA graphics cards. So that's the history of things. And now we're building a set of brand new visualization facilities. In Newcastle, we've got one running now, which is a very widescreen rear projected system, which we use for seminars and also for teaching. This is our teaching arrangement for teaching visualization. So we give people individual workstations and the big screen to work on. This is a 2-projector blended system, and technology in that looks good, but costs us maintenance time. We're continually realigning projector systems. And you'll see in a second that we're moving away from more complex systems to much more reliable, repeatable systems for reasons that I will explain. From all of this experience of building these different systems, one of the things I've come to ask very often now from visualization people who come and try and sell me things is, will it run PowerPoint? Which I'm kind of sad to say, but is a very good question for testing how easy it's going to be to attach things to it and to use it. And if it can, then I know at least a certain group of my users will come in with their laptops and use it, as well as drive it to more high-end uses. People these days also want wireless screen connections, but the kind of background infrastructure we put in. Want it to be easy to maintain. I meant the multi-projector, multi-blending systems have their challenges. And this time round, in this series of things I'll show you, we're very much aiming for a standard aspect ratio across all our platforms, so that when we produce content, it's in a 16:9 or 16:10 aspect ratio, and we can send that to several of our sites around the world and know that people are getting a similar experience. Almost always, we're going for rear projection so that we can have film crews film our users in front of their data, something that proved to be extremely popular as soon as we put it in at Durham. And that requires, at the moment, lots of discussions with architects to make a large space which has nothing in it except a small projector and lots of room for light. But we, in the end, win the arguments. We're also after bright, high-resolution, high-speed screens, and very simple interaction systems, at least as part of the portfolio of systems that we use. So mice are ubiquitous for a reason. They're very easy to use. You get good motor control. And not having a mouse in there would make it very difficult. But there's a few wow factor things we put into. So after all these years of building things, that's what we're trying to do. In our next visualization lab, which will be ready running in August, we've got 2 spaces, actually, an event space, 100-seat theatre, and a small decision theatre, more specialist visualization room for about 15 to 20 people. And they're going to look a bit like this. I have 4K projection onto this back wall, sound and lighting rigs up here. And in the decision theatre, which is more interesting, we'll have the large rear projected screen in here, tracking systems, perhaps, interaction systems. But my interest here is being able to present the content we produce as high image quality as we can get. Because when people go into a room and see something, they don't want to see fuzzy, messy things. They want to see very clear, very crisp imaging. OK. And it may well look like this in terms of the layout of the space. And for stereo buffs, we're trying to get a region of carpet 2 meters deep at the front of the screen that people don't go any closer than. So there's a guide to them not to get too close to the screen. In this particular setup, pretty much all parts of the room have a 60-degree angle of view, which gives us an IMAX definition of immersive. So calling this the immersive decision theatre. And then we just won something over £50 million worth of funding to build a new building, the National Innovation Centre for Data. And this will have another visualization suite in it with a different purpose and other facilities. So this is not quite what the building will look like, but you'll see a big thing on the end. It's going to have a big external screen so that we can broadcast data to the world. And the aim there is literally for the building to be a beacon for visualization. Sadly, the architect told me just before I left that it's not going to be that big. But everyone who's seen it, all the people who might use it, have been enthused by the size of the external screen. On the inside, we're trying to build a team environment so we can have at least small groups of people working around display systems mounted on walls, and then pulling back to a shared projection system in the center of the room. And that gives us a different way of working to the current setups, and is intended to support slightly more routine visualization. We bring companies in to do visualization. And we'll also have a setup, obviously, for just a small audience. So, that's good timing. It took me about 10 minutes. Over the years, the more I've worked in visualization, the more interested I'm becoming in the images and the images we generate and what's in them, rather than in trying to build more advanced display technologies. Because we get, unlike 20 years ago, we get more and more people who expect to be able to produce visualizations themselves and don't want visualization scientists in the way. And this is one of the projects we're working on at the moment, the Newcastle Urban Observatory. So this is a set of IoT sensors across the city of Newcastle, sensing about 100,000 readings a day, storing them in a publicly accessible database. So you can go to this link and access all the data for the last 2 years nearly from all the sensors as they've been added. It's the largest open data resource for urban data in the UK. And the observers, Phil and Rich, don't really know what people want to do with the data yet. They're asking us the question, as many people do, what should we do with our data? So we're going to try and draw some pictures of it. And to do that, we're building a cloud-based visualization system. So we're not trying to put hardware into our labs, we're trying to put it into the cloud. So if Dave's still here, thanks to NVIDIA and their GPUs in the cloud. We're building architectures based around that, where all of the visualization system is cloud side, and all we're doing on the client side is display of pixels and event interaction. And we're building two types of system like this. One is the high-quality, slow-speed system based on a Blender render farm. I'll show you some outputs from in a second. And then also an alternative one based around Unity. And there's 2 or 3 reasons for building it in the cloud that were very appealing to us. One is we can use many different client platforms without requiring people to have high-performance computers. That's important to us when we're doing work in countries without great amounts of funding. And the other is we can send it to our own sites around the world. So we've got 3 or 4 different campuses, and we want everyone to have access to the same quality visualization. This is one of the pilot visualizations we're doing. So these are sensors around our building in Newcastle. This is a 3D LiDAR scan map of the whole of the UK. And we capture the data from the sensors via the database and send it to US East Coast servers in Azure, actually, where the images are continuously rendered. And if Dan can do it, I'm going to try and show you a 3D version of this picture. We currently have 3 outputs you can subscribe to. You can get an HD, a 4K, or a stereo 3D output. So we're trying with this particular thing to look at how we use Blender as a rendering engine for visualizations of data. And although we're not, in terms of the visualization, very far along yet, we have a rendering system behind this that's cloud-based MapReduce system. So we'll take in requests from a client on a web browser and produce visualizations for you. What does this say? This was today, 1st February, and the average temperature in Newcastle has gone up to a toasty 8.3 degrees. It was 0.1 when I left, so there you go. So, but trying to produce this back to a web browser in stereo is interesting, and it's a great shame about the demise of 3D TV, because that was a good platform for us. Okay, Dan, if you can switch back to the slides. So this gives us a platform for visualization research into the future, and I'll show you some of the things we're looking at. So one is the scalability of the cloud-based side of the system. And I won't go through the tools because I'm getting close to running out of time, but there's a set of standard tools we're using to be able to deploy into the cloud grab as many servers as we need and then shut them down quite quickly. So Steve and Mark are working on that, and also a web client-side version of that. Our current render time on a single HD frame has gone down from 40 to about 10 seconds using 8 render nodes, but we're doing various things. For 4K frames, you need it, of course, to use more nodes. But we're just at the very beginnings of testing the system. Where we're going with this is, at the moment, we're replacing the topographical 3D LiDAR with a 3D scan of the city, and trying to ask the question, how do we use this as a backdrop for data and analytics? So this is the 3D scan, this current one from Northumbria, in a joint collaboration with them. What we want to ask is, how do you add labels and data to cities in a comprehensible way, in ways that sometimes are not always working that well? And so here's one thing we're starting to do, is just looking at how we put sensor locations into the city. Again, this is using Blender as a rendering engine. And one of the questions is here that we're about to ask is, how do we put sensor locations in real positions when there are things like trees in the way? And how do we get data to convey messages to people? And we're looking at that with people like Siemens to convey data about traffic to different groups of people. So audiences such as the public, technical experts, and policymakers all need different types of visualization. So, we're creating scalable cloud-based visualization systems to drive visualization hardware in our different labs around the world. And we're trying to make standards that allow us to draw the same picture somewhere in the cloud, ship it to our Singapore, our Malaysia, or our London campuses, and get the same quality experience in all of those places. It gives us some kind of inclusivity to our research in the future. So, I think that's all I'm going to say. Thank you very much.